Hi, welcome back to this course on computational thermodynamics and kinetics of materials. Let's continue with more thermocalc console mode examples today. Right? We introduced how console mode works. We have done a single point equilibrium in the last class. In this class, we'll make a binary phase diagram, something that we have done in the graphical user mode, so that we get oriented to how to draw a phase diagram using console mode. And then we will take that knowledge to draw higher level, more complex diagrams, such as pseudo binary sections. Right. So this is what we are going to make, FECR binary phase diagram. Okay, we have done this already in graphical user mode. Now procedure in the software. Now we are going to use the console mode and do single point equilibrium first. Okay, single point equilibrium has to be done in console mode, no matter what calculations we are going to do afterwards, because the single point equilibrium value is kind of the starting value from where the other let's say compositions or temperature ranges that we give will be calculated starting from the compositional temperature of single point equilibrium. So the entire scanning of the space that we are giving will be calculated based on this initial point. Now do single point equilibrium, use short syntaxes is given here. Basically we are going to use some short forms of syntaxes, and once we have done the equilibrium single point equilibrium calculation, then we can set access variables 1 and 2. 1 will be the composition of chromium, the mass fraction of chromium going all the way from 0 to 1. And what is this double comma, I will explain. And this set access variable 2 is going to be temperature, the small t or capital T, both are temperature, and the temperature range is given here. Once we set two access variables, which is 1, which is 2, doesn't matter. Once we set two access variables, we can do mapping. So this map is again nothing but calculating the equilibrium at different combinations of temperature and composition. Okay, what the software basically does is it splits the 0 to 1 into multiple intervals, discrete points of composition, and similarly this temperature interval also is split into equal intervals of composition. Once that is done, at those combinations of compositions and temperatures, it will treat this thing as a single point. Okay, we have defined a single point using composition and temperature. It will treat it like that, and then do the equilibrium calculation. Since it does equilibrium calculation for all those combinations of compositions and temperatures, we call it mapping. Okay, and once mapping is over, we can go to post module. And set the diagram axis for the actual plot. Here we have to be careful what is in the x and what is in the y. Where we set the set axis variable, we don't need to bother whether the composition is second variable or first variable. But here we have to be careful. If we want composition of chromium in x axis, we have to use set diagram axis x, and this is weight percent of chromium or mass percent of chromium. We can use this, and then set diagram axis y as temperature. This T is for Kelvin. If we want the temperature scale in degree Celsius, then we have to use T-C. Okay, so let's see how to do that in the software. I'm opening thermocalc. I'm going to click on this fourth icon in the top, switch to console mode. Now we are in console mode. So here we have to first do the single point equilibrium. Okay, so before starting, let's set a log file. It's a good habit. Set log file. I am using S-L-F. Set log file. Enter. It's asking me location and file name. In the documents, I am giving example 2. Okay, ex2.tcm. Save. Heading is going to be CRFE hyphen phase. I will type PD. Okay, phase diagram. CRFE PD. That's going to be our heading of the log file. Then go data. So if we do this, it will go to database module. You see, instead of typing go to module and then database, I am typing go data. Okay, type go data, go to this TDB module. FE demo is selected by default. We are okay with that. So here we can define system FECR. Okay, everything in one single line. Define system, define hyphen system. Okay, define system space FE space CR. Enter. Okay, it says define system FECR defined. Okay, so if you enter any element which is not there in the database, it will define only those elements which are there in the database, and it will say the other element is not defined. Okay, so now FE and CR both are defined, so we are okay with that. Now type get, get. Instead of get data, I am typing get. Okay, enter. Okay, now we are back to this TDB module. Here things are okay. The data is retrieved. That's the meaning of it. And here we can go to poly module again. Go poly, enter. Okay, instead of typing go to module then poly, we are typing go poly. Now we are in poly mode. So to do the single point equilibrium, you have to set conditions, right? So I'm going to use some short forms. Before doing that, I am putting a question mark here to tell you how to use these short forms. Question mark and enter. You will see what are the possible syntaxes, commands that we can use in poly module. Add initial equilibrium, go to module, reinitiate module, advanced options, save workspaces, and so on, right? So here if you carefully see, there is this set condition. See, set condition is here. Is there any other command that starts with S and then after hyphen any other syntax that starts with C? First syntax should be set, second syntax should be starting with C. Okay, is there anything else that has this kind of a form? That we have to carefully see. If you see, there is nothing else that says set hyphen and then starting with C. It's nothing like that. Okay. Okay, so now we have made sure that there is nothing that is conflicting with S hyphen C. If we type S hyphen C, S will stand for set, hyphen will, the C will stand for condition. Okay, this hyphen or underscore are same. Okay, so that's what we are going to do. Instead of typing set condition, we are going to type S hyphen C. Okay, in fact, I started with set log file, SLF, even that won't conflict with any other syntax in sys module. Okay, so here S hyphen C does not conflict with any other syntax in this poly module. So we are typing that S hyphen C, then space, we have to define pressure, temperature, number of moles and composition. Pressure equals 1E5. This is enough. This is 1 multiplied by 10 power 5. Then T equals 1000. We can choose any temperature between 298 and 2200. Okay. Temperature is done. Number of moles equals 1. Then some value for the mole fraction in the range we are looking for. Let's say 0.1. Okay. This is mole fraction of chromium 0.1, like 10 mass percent. That's all. So we have set all the necessary conditions here itself in one single line. Okay. Enter. Then list condition to check whether degrees of freedom are 0. Here you can see L-C I have typed for list condition, and degrees of freedom 0 is there, right? So now we have set all the necessary conditions to define a single point. Okay, that's all. Then compute equilibrium, C-E. Now equilibrium is calculated. If we want to see the results of single point equilibrium, we can list equilibrium and see, but that's not necessary. We are interested in making the phase diagram. So there is no need to see whether what is the result of this single point equilibrium at 1000 Kelvin and mole fraction of 0.1. Okay, we don't need to see that. As long as compute equilibrium is done successfully, we are okay with that. If there is any error, it will show the error, so and so, things like that. So now there is no error displayed, so we are fine. We can now go to setting the access variable. Okay, if you imagine in the graphical user mode, when we go for phase diagram template, we could see two different access variables we could set in the bottom of that configuration window, right? So here we are going to set access variables manually. Set access variable. In fact, you can use s-a-v also. First time I am typing this syntax, so I am typing it in full. Set access variable 1. We don't need to say x and y. We have to say 1 and 2. Okay. Set access variable 1 is going to be WCR. This is mass fraction of chromium, and it will go from 0. So space 0 space 1. Okay. Space 0 space 1. Okay. If I type enter now, it will ask another question. If I type enter now, it will ask this question. Increment is 0.025. By default, it is giving this option of increment. What is this increment? It is between 0 and 1. In what increments it should choose multiple compositions. That's what it is asking. So when we say increment 0.025, if we accept this, it means that we are splitting 0 to 1 into 40 different intervals, and we are okay with that sort of splitting. Okay, so this is actually okay. If you feel there is any more accuracy required in certain regions of the phase diagram where something is doubtful, if you want to recalculate, possibly you can refine this interval. Things like that you can try, but it will obviously increase the calculation time a bit. That's all. Okay, so enter. So if you don't want this question to be asked, you can do a modification. I will do that for temperature now. Okay, set access variable temperature. Sorry, 2 is going to be temperature. Okay, second access variable is going to be temperature, and space 298 minimum value, 2200 maximum value. Okay, so this interval will be split into 40 parts, and it will ask me whether that increment level is okay or not. Okay, if I want to skip that particular step, or just accept what it will show in the next step, I can put a double comma here. Okay, and enter. That's all. Okay, now we have set two access variables. This is where we do mapping. MAP means calculate single point equilibriums in all those combinations, 40 composition, 40 temperature values. Calculate the equilibrium in all those points, and then it will combine all the results and save in a file. That's all. That will be the job of poly module. Once that calculation is done, we can go to post module and then plot the diagram. Okay, so after typing map, enter, it will take some time. It shows all the things that you usually see in the event log in the graphical user mode. Those things appear here. So it takes a while. Yeah, now it's done. So we are back to poly now. You can see just above this there is a location given. C users, my name is there, my computer, app data, local, temperature, result 001.poly3, right? So this poly3 extension file is the buffer file where the results are saved right now. Okay, so now we are going to go to post module, post, enter. Here if we set the diagram axis, set diagram axis space x, set hyphen diagram hyphen axis, you can type s hyphen d hyphen a, that would do. Okay, set diagram axis x, we want weight percent or mass percent of chromium, so w hyphen p is the syntax for that. Give a space and cr, not w in bracket cr, this is weight percent, so w hyphen p space cr, enter. Okay, then again set diagram axis, set diagram axis space y is going to be temperature. Let's leave it in Kelvin. Okay. Enter. So now set diagram axes are set. We have to type plot, P-L-O-T, plot, enter. Okay, so you can see in the right side, results window is here. You can see the diagram. Okay, it does not come with the tie lines and all by default. Anything that you want in the diagram, you can add. Okay, so right now you can label the things. Add label, sigma phase is here. Okay, so you are by now you should be familiar with this diagram. You have plotted it already a couple of times. So FCCA1. Okay, and this break region is BCC, right? Yeah, so this is how you make a binary phase diagram, right? So important difference from the single point equilibrium is this. When you have done single point equilibrium, you did not bother about setting the axis variable and mapping. Here you have to set couple of axis variables and map, and then set the axis diagram axis in the post and then plot the diagram. That's the difference compared to the previous exercise. So now with this phase diagram making skill in our hand, we can go for making more complex phase diagrams. We can think about this thing. This is where we said compared to graphical mode, it's better we go and try this out in the console mode. So this diagram where chromium iron ratio is going to stay 1:1. Okay, and if we want to make this vertical section through this, then how do we make it in console mode? Let's see that. I'm clicking on this console. There is a plus mark next to that. I'm clicking that. I'm opening a new console. We can work on this. Okay. Set log file CRFENI, enter. Meaning I did not enter after SLF. I gave a space and gave a name. This will be the file name, and in the default folder, documents folder, the log file will be, the TCM file will be created with this file name CRFENI. Okay, so heading is going to be CRFE NI. Okay, basically to say that CRFE is going to have some ratio. You can give a bigger name also if you wish. Use hyphens so that there is a continuity and it is a single word. Okay, right. Now we are back to sys module. We can go to database module. Go data. We are in FE demo. Define system. FE CRNI. 3 elements defined. Enter. It says FE CRNI defined. Okay, we are fine with that. Then type get. GET. Enter. Okay. Yeah. Now here we can go to poly module. Go poly. Okay. So here we have to set condition. Now set condition in the binary case, what we have done is straightforward. Since we had 2 elements, we have entered composition of 1 element now. 1 element there. Here we have 3 elements. We have defined 3 elements. How many composition variables should we enter? If there are 3 elements, 2 composition variables are to be entered. Only then the degrees of freedom will be 0. Okay, that's how the software works. We have to enter 2 composition variables. So 2 composition variables, if we enter chromium value or nickel value, or chromium or iron value, what will happen? It will not tell anything about fixing the ratio between chromium and iron as 1:1. Okay, so now how do we do this? Now one more rule in this console mode is that after this equal symbol, okay, we say W in bracket CR equals some number 0.1 we entered in the last case. So here that equal symbol, beyond that only numbers should be entered. That is a problem here. Possibly NONE, none kind of words can be written. That is to cancel some condition. If at all you entered something wrong, you can type, let's say WCR and WFE you have entered in the previous exercise. Then you were thinking how do you correct that? You should have not entered WFE, but you have entered. Then what you can do in the next step, you can say set condition WFE equals none. It means it is removed. keeping that rule in mind, after equal symbol there should be only numbers. How do we set the condition now? Two composition variables we have to set. Okay, let's try that. Set condition p equals 1e5, n equals 1. These things we don't generally change. Temperature, some value in the range that we are looking for, t equals 1000 I am entering. Then composition variables, since we are going to keep the nickel content in the x-axis, nickel is going to change. As nickel changes, iron and chromium decrease, but they decrease in equal ratio. Okay, that's the condition. Therefore, nickel is the one which will vary in the x-axis, right? So for that nickel, we have to enter some number here. Use mole fraction here, x of Ni. Okay, x means mole fraction. Okay, instead of W, we are using x now. X of Ni equals 0.1. So nickel content is entered some number. So now if we check list condition, we will obviously see 1 degrees of freedom left. Okay, we have to define one more composition variable, set condition x of CR is equal to x of Fe, right, throughout the diagram. If we bring that x of Fe to the left side, then x of CR minus x of Fe will be equal to 0. Now after equal symbol there is only number. Okay, so in this way we are imposing that CR and Fe should maintain same mole percent, same molar ratio. Okay, so this is how you set the condition to impose some ratio. Okay, x of CR minus x of Fe equals 0. Now if you list condition and see, degrees of freedom is 0. Okay, here you can compute equilibrium. This is calculating the single point equilibrium, keeping x of Na as 0.1 and x of Fe and x of CR as 0.45, 0.45. That's the meaning here. So now once the compute equilibrium is done, we can set the axis variable 1 and we will change x of Ni, not x of CR or not x of Fe. Although we have entered the condition, you may ask, if you set x of CR and make x of CR vary, let iron vary equally. If you impose that kind of condition and try to set x of CR here, it won't work. What will work is, for what mole fraction you have set a number, only this you have to enter here in the set axis variable. Okay, these are some points with the software. Once you start using this, these things will become familiar. Okay, set axis variable 1, x of Ni space 0 space 1. Okay, double comma, enter. So nickel is going to go all the way from 0 to 1. Then set axis variable 2 is going to be temperature from 298 to 2200. Enter. Done. Then map. It takes slightly more time. Now we are back to poly. The buffer file is saved here. Then we can go to post, set diagram axis. SDA X is going to be mole percent of nickel. Mole percent of nickel, enter. Set diagram axis Y temperature. Okay, enter. Plot. PL is fine for plot. Okay, plot. Now we got the diagram. Okay, you see, now nothing is labeled here, and instead of 298 the diagram starts at 200. We can correct that. Okay, how do we correct that? Set scaling status, SSS means set scaling status, enter. It says the command in full is set scaling status. Which axis we want to change? Y axis length. Type Y, enter. Automatic scaling, yes or no? We don't want automatic scaling. No is selected by default, enter. And we have to set the minimum value now. Let's set 298. We have to set the maximum value 2200, enter, plot. Okay, type plot again and enter. Now you got the diagram from starting from 298. Okay, add label, right? So I'm just going to right click somewhere here, add label, and show details, to show you that Cr and Fe follow same mole fraction. You see, mole fraction Cr 0.04, iron 0.04. Okay, in the right extreme of diagram somewhere. In left extreme somewhere, let me right click, add label, show details. You can see here, mole fraction chromium 0.47561, iron 0.47561. So Cr and Fe maintain same ratio throughout. Okay, yeah. So you can right click, save as, give a file extension and location, and save it. Okay, right now I'm cancelling it. Right, so this is the key procedure in software. Only the major change that we have done is given here. Set condition t equals 1000, n equals 1, x of ni equals 0.1, x of Cr minus x of Fe equals 0. So this is where some tricky things are there. In order to think about conditions, this is how you set this. Okay, set access variable 1 should be x of ni rather than any other x. Cr or Fe you should not use, you should use x of ni, because only for that you have set a number here. Okay, these are the two important things when you draw a vertical section compared to a simple binary phase diagram. Okay, right. Thank you. I hope the lecture is useful. See you in the next class.